Hey guys, welcome to another week. Today we're going through test 25 in Power Mathematical Reasoning. So let's just jump straight in. Question 1. What is the total number of times that the hour hand, minute hand, and second hand go around in a circular clock in a day? Now to tackle this question, it's quite straightforward in the sense that we just need to look at each component. So the hour hand, minute, and second. So first, the hour hand. How many times does the hour hand go around in a whole day? Now remember, the whole day is referring to 24 hours. So in 24 hours, how many times does the hour hand, right, go around? Well, it's actually twice, right? Because each rotation it does refers to 12 hours, and because we have 24 hours in a day, it should only go around twice. Minute hand, let's have a look. Minute hand goes around the clock once every hour. And so every hour the minute hand does one full rotation. So in 24 hours then, it must do 24 hours of rotation. And the second hand, let's have a look. The second hand goes around the clock how many times? Once every minute, right? Once every minute. And in 24 hours, how many minutes are there? Well, if there's 60 minutes in an hour and there's 24 hours, this must be the total amount of minutes we have, don't we? So we just add all these numbers up and we get 1466, which gives us our answer C. Alright, let's move on. Look at question 2. These 9 congruent rectangles from a larger rectangle whose area is 720 squared centimeters. What is the perimeter of the larger rectangle? Okay. So to approach this question, we'll have to find out the area of each rectangle. So I'm just going to draw this separately here. Imagine this is our rectangle enlarged. So if all these rectangles together, we have a total of 1, 2, 3, 4, 5, 6, 7, 8, and 9. If we have 9 rectangles that form an area of 720 squared centimeters, then 720 squared centimeters divided by 9 would give us the area of each, right? Okay, so now that we know that each rectangle has an area of 80 squared centimeters, then we can start to find the dimensions of these rectangles. Now, why do I want to find out the dimensions? Because it's asking for the perimeter, right? And we need to know the length and width to know the perimeter. Now, I've named these components L and W, standing for length and width, okay? So don't get confused. Now from here, how do I find out the length and width? Well, we can't just do it without any further evidence. We need this. Can you guys see how? 1, 2, 3, 4, 5 widths, right? 5 widths, 5 width length is the same as 1, 2, 3, 4 length, right? 5 widths is the same as 4 lengths, right? So because this is the case, and by the way, this is so because opposite sides on rectangles are equal, right? They're equal. So after we've established that, then we just need to do trial and error from here. So I need to find out two pairs of numbers that when multiplied together get 80. So I'm going to start off. Let's say width is 5, then length is 16. Okay, that does make 80. So let's check it out over here. 5 width. 5 times 5 is 25. 4 times length, which is 16. 4, 16. These two should be equal together. This must comply with this rule, right? So 5 times 5 is 25. Is that equal to 64? No. So we know that 5 and 16 are not the pair. Let's go into another pair. What do we have? If you guessed 8 and 10, well done to you, because indeed this is the answer. Let's have a look. 8 and 10. If we apply in this rule, 5w equals 4l, our w is 8, so 5 times 8 should be equal to 4 times length, which is 10. And let's check if it is. 40 does indeed equal to 40. So yes, we have found our length and width. Now, if our length equals to 8 and our width is equal to, no, the other way around, length is equal to 10 and width is equal to 8, then our perimeter, therefore, is equal to 10 plus 8 plus 8, which is, actually, it says larger rectangle, doesn't it? Whoops, that's not right. Okay, larger rectangle. Sorry, guys. Larger rectangle, the perimeter equals to 5 width plus 4. Actually, let's do it this way. Since we know that the width is 8 and there's 5 of them, it's 40. The other side is also 40. Plus, what's this side? Length. This side over here is length plus width. So what's length plus width? It's 18. So 18 plus 18. So 40 plus 40 plus 18 plus 18 is 116. And that is why C is our answer. Alright, let's move on to the next question. In question 3, we have this. On the figure below, find the sum of the marked angles. Now, to solve this question, we're actually going to follow 2 rules here. Number 1, I've written it down already. Angle sum of triangle is 180 degrees. Number 2, vertically opposite angles are equal. Okay? And what I mean by that is, if I draw 2 straight lines, these angles here that I've listed are actually of the same value. Similarly, this angle over here is going to be of the same angle. Okay? So, once we've established that, let's have a tackle at our question. So if angle sum of triangle is 180, then we can actually find the angle sum of this quadrilateral inside. How? Because this quadrilateral is only 2 triangles. So if it's 2 triangles and we know each triangle of sum is 180, then this interior angle sum 2, 3, 4 must be 360 degrees, right? Then let's have a look at the angles outside. This angle is the same as this angle listed in red because vertically opposite angles are equal, right? Similarly, we have this angle equal to this, this and this, and this and this. If these angles are equal, then that means we have a whole new quadrilateral outside as well, right? And what do we say the angle sum of quadrilateral was? It was also equally 360 degrees, meaning that our total angle sum comes to 720 degrees. And that would be your answer D. Hopefully that makes sense. Question number 4. The average of these 3 numbers, A, B, and C, is 2A. What is the average of B and C? Now, this question might seem tricky at first, but it's a matter of listing out what you know. So if and when you don't know something, just list out what you know. So average of 3 numbers, so A plus B plus C over, how many numbers are there? 1, 2, 3. So we divide that by 3. This is what you call average of these numbers is 2A. We know that now. Okay, interesting. And the question asks, what is the average of B and C? How do we find our average of B and C? It's B plus C over 1, 2, right? So this is the question we're asked for. This is the question. given that this is the question, how do we work out the answer? Well, from this clue, we can know that a plus b plus c is actually 6a. How do I do that? Before you panic, all I did was times 3 to both sides to get rid of this denominator 3, okay? So if I times 3, I can cancel these numbers out, and on your right side, it becomes 6a, okay? So a plus b plus c, now we know, is 6a. Now, let's have a look back at the question. Question asked for b plus c. That's something we don't know, right? And because we don't know that, and actually, guys, another clue is, look at the answers. They're all in terms of a. In terms of a. Meaning that we have to somehow convert b plus c in terms of a. Okay? And here we have it exactly like that. B plus c, if a plus b plus c is 6a, then b plus c is 6a minus 5. Again, all I've done from here to here is minus a, and I get 5, I get b plus c. Okay? So b plus c is actually 6a, oh, not minus 5. Oops. It's minus a. Okay? It's actually going to be 5a. So we know b plus c is 5a. Then we actually have the answer to our question, because b plus c, 5a, then b plus c over 2 must be the same as 5a over 2. Okay? And here we have it. That is our option A. Alright, question number 5. Fractions. What fractions of the sums are possible on a pair of dice to produce a greater number than 7? Okay, so we have 2 die. 2 dice. 1, 2, and we just roll them, imagine, simultaneously. And it asks for possibilities of greater than 7, okay? So in a pair of die, guys, what is the maximum that you can get? Maximum sum. It should be 12, because maximum on one die is 6, the other is also 6, so we add them to get 12. And what's the smallest we can get? Or the smallest that the question is asking for? Greater than 7, which has to be 8. So we're looking from the ranges of 8 to 12, okay? So let's see how many numbers add up to 8 first. We have 2 and 6, 3, 5, 4 and 4, 5 and 3, and 6 and 2. Okay? Don't worry about the repeating right now. That's not our concern, because I'll show you later. Then for 9, we have 3, 6, 4, 5, 5, 4, and 6, 3. Now let's have a look at number 10. We have 4, 6, 5, 5, and 6, 4. Let's have a look at 11, 5, 6, 6, 5, and number 12. What makes 12? Well, it's just 6 and 6. Okay, so now that we know that, we know how many total possible options there are to make a number greater than 7. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we found out there is 15 possible options. Now we need to find out of how many total options, right? Well, if we think about it, if each die has 6 numbers to choose from, right? And each number has 6 possibilities, right? Then it will be 6 times 6, right? So let that sink in. I have 6 numbers on one die. Each of those numbers can pair up with every other number on the other die. So there's 6 for one number, 6 for the other, and so on for 6 numbers. So 6 times 6. So we've got 15 over 36 as our possibilities. And we can simplify this. Divide top and bottom by 3. 5 over 12. So our answer we get is E. Alright guys, key points from this test. Point number 1, when in doubt, guess and check. And where do I pull this out from? I pull this out from question number 2. Remember how we had to find, after finding out the area of one rectangle, we had to find out the width and length of it, right? And we did that via a process of elimination, using the other criteria, which was 5w equal to 4l, by substituting numbers in. So first we tried 5 and 16. Although 5 and 16 multiplied together was indeed 80, this 5w, so 5 times 5, was not equal to 4 times 16. So therefore we concluded that can't be the pair that we're looking for. So we tried 8 and 10, and surely enough, it did work. So in that manner, I want you guys to use guess and check when you don't know how to solve it any other way else. Point number 2, angle sum of quadrilateral is 360 degrees and vertically opposite angles are equal. Okay, and I'm sure you guys know that that's from this question over here, question number 3. Write that down if you need to, it's quite important. And point number 3, list all possible outcomes when dealing with fractions, and obviously that's from question number 5. As we did, you might be a bit meticulous, but if you can't do it in your head, it's actually a lot better to write it out, okay? And I'll strongly recommend writing it out first. So yeah, that's it guys, and I hope you guys learned something. I'll see you